Okay, chapter 15, problem number 2. Basically, it says redo problem 1. It's got some goofiness to it. It says compute the ultimate bearing capacity by the Meyerhof method and then use the Q sub F, the critical depth concept to come up with Q sub F. And then it says uh, find Q sub A with an F factor of safety of 2.5. So apparently it doesn't want you to add QB to the QA and then divide both of them by 2.5. So anyway, that's the way the book went. The book made an egregious error, left out a decimal place, so it's off by a factor of 10 in one part. So I'm fix that. So here's our givens. Also, you need to look at figure 15.10. This little diagram is really important. I've recreated it further down the problem. So the first thing I have to do is figure out what gamma saturated is. So if I go to equation 317a and plug and chug, I get gamma sats 20.75. The buoyant unit weight, or the effective unit weight, is gamma sat minus gamma w. Q prime sub 0 is the buoyant unit weight times L, which is basically the same thing as gamma H. So that gives me 131.24. The area of the pile at the base is pi d squared over 4, which is 0.16 meters squared. So for 35 degrees and n sub q, that gives me 140. So equation 15.6 says Q sub B equals Q prime sub 0 times NQ, which is 18,374 kilonewtons per meter squared, or kilopascals, same thing. Um, but I can't just stop there. I have to actually calculate this value QBL, which is 50 times NQ times the tangent of phi. I called it phi 1. And that gives me 4901. So the smaller of those two numbers is what I should use to calculate the bearing capacity. So I wrote this little MathCAD program to check to see if QB is less than QBL. If it is, then I can go with QB. If it's not, I have to go with QBL. So it tells us what we already know, that Q allowable is equal to 4901 kilonewtons per meter squared. So the bearing capacity, ultimate bearing capacity, is A sub B times Q allowable is 780 kilonewtons. So let's look at the frictional part of this pile. So L sub C is 20D. This, if you look at section 15.7 at the bottom of page 629, it says that. So the diameter of the pile times 20 gives me 9 meters. The friction is the buoyant unit weight times the critical depth times the tangent of delta. Delta is the angle of friction between the soil and the pile. Remember, we get that from lab tests. A direct shear test will give you that number. So we get 35.84. The circumference of the pile is equal to pi d, which is 1.41 meters. So Q sub F is the area under this curve here. So FSL is 35.83. The critical depth is 9. The difference is 12 minus 9. That's 3. So when I put these together, I find the area under the upper part of the curve. That's a triangle, so the formula is 1/2 base times height times F sub SL. Um, Actually, that is F sub SL. And then the second part is just the area of this rectangle, which is L minus L sub C, which is 3, times the circumference times FSL. So when I put those together, I get about 380. Divide that by a factor of safety of 2.5, and the answer for the friction is 151.94.